We should be live. Let's double check that. Yeah, looks like we are live. All right. So today we are going to resume our series on reading through the Lingua Franca manual. I think we are almost done with the main section of the documentation. So today I think we are gonna look at generic reactors and preambles. Maybe distributed execution. We'll see how that pans out. Depending on how that goes, we may look into some more ontology stuff from Palantir, or again, it just depends on, I guess, how I'm feeling. Or we may actually look at some actually, I don't know. I'm just gonna say that we are gonna do some reading from the handbook of Lingua Franca. Just targeting these two chapters here, generic reactors and preambles, and then we'll see after that what happens. Let's see, let me just need to double check something. Gosh, something is off with my machine, man. I think what it is that since I don't turn it off, and I have things like Slack and some other memory hungry applications, I think it's just eating up my resources. Because I mean, this is a Mac Mini, it's not supposed to be sluggish. Wait, just realized. Is there a copyright thingy on one of my videos? I guess I never bothered to check. Let me see. Oh. Oh, so that's what it is. Gosh, I should have known. Then, okay, sorry. I'm just looking in the back end of videos on the channel, and there was something about copyright. Because I did some commenting on a scene in Interstellar. But then it's telling me that like they're just flagging it. It's not actually affecting the visibility of the video. So I don't know, I guess it's fine. Yeah, I mean, it seems like it's fine. It's not saying anything about deleting it or whatever. So I guess it's just whatever. Anyway, alright, let's just do the thing. Okay? Let's do the thing. We are going to read Let me see. It's, gosh, look at this. The mouse takes forever to respond. I think I need to turn off my computer and turn it back on. You know, because that is the ultimate IT problem solving technique. Turn it off, turn it back on. Alright, generic reactors. Sometimes it is useful to implement a generic pattern without knowing the concrete types used. For instance, it could be useful to implement a delay reactor that forwards all values it received with a fixed delay regardless of the data type. For this pattern, it is not required to know the concrete type in advance, and we would like to reuse the same logic for different types. This can be achieved with generic reactors in LF. Consider the following. Okay, so we have the input port, the output port, logical action with a delay. If I remember right, the delay here is relative to the initial startup time. Yeah, I think so. We'll just assume that that's what it is. Well, I guess we can double check. Logical actions. Timers are useful to trigger reactions once or periodically. Actions are used to trigger reactions more irregularly. An action, like an output or input port, can carry data, but unlike a port, an action is visible only within the reactor. There are two kinds of actions, logical and physical. A logical action is used by a reactor to schedule a trigger at a fixed logical time interval d into the future. The interval time, the time interval d, which is called the delay, is relative to the logical time t at which the scheduling occurs. Okay. So it's definitely not what I said. So it's not just startup time, it's relative to when it's triggered. If a reaction executes a logical time t and schedules an action A with delay d, then any reaction that is triggered by A will be invoked at the logical time t plus d. Logical actions are always scheduled within a reaction of the reactor that declares the action. Oh, a reaction within the reactor. Okay. Okay. All right. We're back to generic reactors. Okay, so the delay will be relative to whatever logical time at this point when invoking this reaction. Sorry, I'm jamming out. Oh, actually, no, I'm not sorry. Um, okay, so reaction A, take your it gets delayed relative to the logical time here. It's pushed to the output port. Wait, what's happening here? I don't think I've come across this before. Out of schedule copy. So, okay, so the types are generic. You just want the value of whatever the generic value is, or the generic type instance. Yeah, what's the deal with schedule copy? I don't think we've seen this one before. So this is how you declare the specific type for the generic reactor. Makes sense. So startup. You set the input port. Okay, so when this gets set, 42, this is gonna run and schedule the logical action. Wait, did I say that it was the logical action was being triggered here? That's not at all what. That's not true at all. It's being triggered here. Anyway, okay, so this happens, which triggers this. Okay, copy. So I'm guessing it's I'm trying to one-shot this without having to look up the documentation for this. So you have the initial, well, you have the action itself. Self-delay is probably on A, because the self cannot be referring to, oh no, you can it? I mean, you have this parameter here. Can you refer to it as self-delay? So this here, you're either referring to this or this. But then again, this is just this here. Like I'm just using the word this. That's not confusing at all. Okay. Okay, so I think what this looks like is that it wants to copy the value that's in the input port in here. It wants to copy this value into whatever placeholder is here. Actually, yeah, that makes sense. So this action carries a payload of type T. So it's copying the instance of T in this port here into here. I guess the self there is just to I mean, I think it's one of those things where you have positional parameters, and so they just have to specify it here so that they can obviously put in the other parameters. But then I'm not sure what the one here is supposed to do. I don't know what the one is supposed to do, but the other stuff now makes sense. This is basically, yeah, setting the payload for the action. Guess one is like a delay. No. Yeah, I don't know what one is supposed to be. Excuse me. And then, of course, when the logical action is triggered, the value just gets passed out into the output port. The example above defines a generic reactor delay which has a type parameter named T. Its input, output, and logical action are all of type T. The logic implemented in the reactions is straightforward. The reaction to in schedules a logical action A with the configured delay and the received value. Okay. The configured delay to this and the received value. The reaction to A simply forwards this value to the output port at a later time. The concrete type T, however, is not relevant for this implementation and will be filled in only when the reactor is instantiated. In our example, the main reactor instantiates delay, specify int as the type to be assigned to T. As a consequence, we can set an integer on these input port and receive an integer on its output port. If we wanted instead to delay a string, we could do this as well. And here it is. Same thing, just using a string in place of the generic placeholder. Reactor definitions may also specify multiple type parameters. Oh, okay. Moreover, type parameters are not limited to ports in actions, but can also be used in state variables, parameters, and methods. For instance, we can define the following reactor: state U, blah blah blah, input in V, okay. This reactor could be instantiated, for example, like this. Nice. I just wonder, is there a limit to how many generic types you can use? Alright, next thing, preamble. Dun, 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 dun. C++. Oh my. Okay, the C one is definitely longer, right? Rust. Barely anything for TypeScript. C++. Is it the same? No, yeah. C is definitely more fleshed out, it seems. So we'll go with that one. Okay. Preamble. Reactions may contain arbitrary target language code, but often it is convenient for that code to invoke external libraries or to share procedure definitions. For either purpose, a reactor may include a preamble section. For example, the following reactor uses the math C library for its trigonometric functions. Alright. By putting the include in a preamble, the library becomes available in all reactions of this reactor. If you wish to have the library available in all reactors in the same file, you can provide a preamble outside the reactor as shown here. Okay. Seems straightforward. You can also use the preamble to define functions that are shared across reactions within a reactor. Wait. Yeah, that seems like oh, okay, I see. So in the first example here, you're importing an external library. And by external, we mean just relative to the actual reactor. Or you can actually have a defined function instead of, importing stuff in. You can just have shared logic in your preamble. Oh, okay. So I read this. The order in which these are printed is arbitrary because the reactions can execute in parallel. I was like, wait a minute. How come? Especially with, specifically because of, the strict rules around the execution order of reactions. But what I forgot is that you don't need to apply those specific rules because there are no side effects. So you can just apply them in parallel. Okay. To share a function across reactors, however, it's a bit trickier. A preamble that is put outside the reactor definition can only contain declarations, not definitions of functions or variables. The following code, for example, would fail to compile. Okay. The compiler will issue a duplicate symbol error because of the function. Now, because the function definition gets repeated in the separate C files generated for the two reactor classes. Oh, I see. When the compiler C code gets linked, the linker will find two definitions of the function add 42. To correct this compile error, the file level preamble should contain only a declaration, not a definition. Oh, but then I guess it needs to be implemented in whatever parent reactor is instantiating the children reactors. The function definition here is put into the main reactor, but it can be put in any reactor defined in a file. Oh, okay, it doesn't have, okay, never mind. It doesn't have to be the main reactor. So as long as it's in one of them. Most header files contain only declarations. And hence can be safely included using include in a file level preamble. If you wish to use a header file that includes both declarations and definitions, then you will need to include it within each reactor that uses it. If you wish to share variables across reactors, similar constraints apply. Note that sharing variables across reactors is strongly discouraged. Then why you guys are allowing it? Come on. Because it can undermine the determinacy. Gosh, why can't I say this word? Determinacy. Okay, determinacy of Lingua Franca. And you may have to implement mutual exclusion logs to access such variables. But it is occasionally justifiable. Oh, no. Share string. Da, da, da. Notice that the use of the extend keyword C, which is required because the definition of the shared string variable will be a separate code-generated C file, the one for man, not the ones for A and B. One subtlety is that if you define symbols that you will use in input, output, or state declarations, then the symbols must be defined in a file level preamble. Specifically, the following code will fail to compile. The compiler will issue an unknown term name error. To correct this, just move the declaration to a file level preamble. Okay. I feel like this is one of those documentation details that only really becomes useful or relevant when you actually are like working on a problem that requires the particular feature. Otherwise, it's just okay. That's how I feel about it right now. Could be wrong. Oof. Alright. This is a long one. Might want to sit for this one. It's in an early stage. Uh, no plan for Windows systems. Alright, let's see if we can power through this. But I think I want to sit down for this actually. Oh. Let's see. Adjust the camera just a little bit. Okay. Okay, so a distributed Lingua Franca program is called a federation. Each reactor within the main reactor is called a federate. The Lingua Franca compiler generates a separate program for each federate and synthesizes the code for the federates to communicate. The federates can be distributed across networks and eventually be able to be written in different target languages, although this is not yet supported. In addition to the federates, there is a program called the RTI, the runtime infrastructure, that coordinates startup and shutdown and may, if the coordination is centralized, mediate communication. The RTI needs to be compiled and installed separately on a system before any federation can execute. It is possible to encapsulate federates in Docker containers for deployment. See containerized execution. Okay, so installation of the OTI. Okay. A minimal federated execution is specified by using the federated keyword instead of main for the main federate. An example is given below. Target C. Federated. C output goes to P input. The federated keyword tells the code generator that the program is to be split into several distinct programs, one for each top-level reactor. When you run the code generator on source federated containing the above code, the following three programs will appear. SND. SND. The root name federated is the name of the LFL from which these are generated. The suffixes S and D come from the names of the top level instances. There will always be one federate for each top level reactor instance. For each, okay, top level, okay. Wait, but again, why is it S and D? None of these are called S and D. And it's C and P, so where does S and D come from? says come from the names of the top level instances, but I don't think that is actually true here. Okay. To run the program, you can simply run being federated, which is a bash script that launches the OTI into other programs. Alternatively, you can manually execute the OTI followed by the two federated programs by starting them on a command line. Federation ID. You may have several federations running on the same machines or even several instances of the same federation. Excuse me. In this case, it is necessary to distinguish between the federations. To accomplish this, you can pass an ID flag, basically an ID parameter, to the OTI, and it federates with an integer that is unique to the particular federation. I'm getting the sense that this is not worth going through at this point in time unless I'm actually building something that requires this feature. Yeah. I feel like this is part of the manual where it's, in order to understand it, it's better to actually have something that you're working on that requires the feature, same as preambles. I guess that's why they are at the bottom of the list here. Yeah. Let's see what's in termination actually. Alright, let's go through termination. I guess we are finishing this big session of the documentation. Tracing. Okay. Developer. Okay. Let's termination. Okay. Shutdown reactions. There are several mechanisms for terminating a lingua franca in an orderly fashion. All of these mechanisms result in a final tag at which any reaction that declares shutdown as a trigger will be invoked. Call that a tag. We call that it. Yo, I don't need your ads, YouTube. Ugh, this is so annoying. Oh no. Oh, not the Downy commercial. Oh boy. Where's the remote? Oh gosh. Okay. I actually have to get up. No. Okay. Okay. All these mechanisms result in a final tag at which any reaction that declares shutdown as a trigger will be invoked. We call that a tag is a tuple, logical time microstep. Excuse me. Other reactions may also be invoked at this final tag, and the order in which reactions are invoked will be constrained by the normal precedence rule. Precedence. The normal precedence rules. If a reaction triggered by shutdown produces outputs, then downstream reactors will also be invoked at the final tag. If the reaction schedules any actions by calling schedule, those will be ignored. Ooh, that's definitely something you want to know about. In fact, any event after the final tag will be ignored. After the completion of the final tag, the program will exit. There are 4 ways to terminate a program: timeout, starvation at the conclusion of some tag. There are no events in the event queue or future tags. Stop request. Some reaction requests that the program terminate. External signal. Program is terminated externally using operating services like Control-C or kill. So for timeout, the last logical time at which reactions should be triggered. The last invocation of reactions will be at tag timeout 0. Wait. Okay. Okay, there's a significant subtlety when using physical connections, which are connections using the syntax. I don't know what to call this. Well, whatever this is. Such connections specify that the tag at the receiving end will be based on the physical time at which the message is received. If the tag assigned at the receiving end is greater than the final tag, then the message is lost. Hence, messages sent near the timeout time are likely to be lost. Alright. Starvation. If a Lingua Franca program has no physical actions, and if at any time during the execution there are no future events waiting to be processed, then there is no possibility for any more reactions to occur and the program will exit. This situation is called starvation. If there is a timer anywhere in the program with a period, then this condition never occurs. One subtlety is that reactions triggered by shutdown will be invoked one microstep later than the last tag at which there was an event. They cannot be invoked at the same tag because it is only after that last tag has completed that the runtime system can be sure that there are no future events. It would not be correct to trigger the shutdown reactions at that point because it would be impossible to respect the required reaction ordering. Starvation termination is not currently implemented for federated execution. Stop request, I feel like that's probably really straightforward. External signal. Oh wait, let me double check. Stop request. Yeah. A central C. Oh, central C. A control C or other kill signal to a running Lingua Franca program will cause execution to stop immediately. For federated programs, each federate in the OTR catches external signals to shut down in an orderly way. When a federate gets such an external signal, it sends a resign message to the OTI and an end of file on each socket connection to another federate. It then closes all sockets and shuts down. The RTI and all the federates should continue running until some other termination condition occurs. When the RTI gets an external signal, it broadcasts a stop request message to all federates. Waits for their replies, chooses the maximum timestamp S on the replies, broadcasts stop granted message to all federated with payload S, and waits for logical time complete messages above. Alright. I would say the last three chapters are the last three chapters for a reason. I don't think that you can fully appreciate them unless you've actually, I guess, have something that you're working on that desperately needs those features. Right. So, I'm not too pressed about them at this point. Okay, so 9:30. Let's see, how long have we been on? Oh, less than an hour. I think that's good. We're making good time. Okay, so actually, let me see. I haven't looked at the blog in a while. Oh man, my computer is slow. No recent post. Alright. We're gonna move on to something else. Distinguished paper. Is this the same journal? I think I said I was gonna look at some ontology stuff in the in the Palantir documentation. Excuse me. Sounds like a good research topic. One-time energy saving tool. Oh, I think I've seen this before. Deterministic parallel execution. I think I've seen that before. Okay. I think I should look into that later. Oh yeah, I remember this. This was some research on combining combining chisel and reactor, and I think chisel is a language for hardware specification. Anyway, let's see what else do I have open. For real-time stream processor wireless communication. All right. Okay, this is TLA Pro stuff. Wait, I don't think I have TLA Plus installed on this machine. At least on this account. Excuse me. Oh yeah, ontology. That's what I originally wanted to actually look into. Actually, yeah, it's interesting. Lately I've been interested in this whole concept of ontologies and stuff like that because Palantir won't shut up about it. But the more you read about it, the more you realize, yeah, actually, it makes really sense. I mean, it makes total sense to make a big deal about the ontology or building an ontology because it really grounds a lot of the ideas and concepts of a system, and one would presume that this can really be of use when it comes to automated reasoning through AI agents and all that. And I did some very light research, I would say, and Palantir did not invent ontologies, whatever. So there are many organizations out there that have dedicated lots of care and, I guess, resources to build or to set up frameworks for building ontologies. In fact, I think there's one that, I don't know if it's BF or IF or something, and it's meant to be some sort of really solid framework from which you can set up building ontologies. Anyway, let's do some reading here. So we've already done the initial stuff in these links. So now we're here. And we've done this, in the previous lectures I've been doing Lingua Franca and ontology stuff together. So to see ontology related stuff that I've done before, it will have to, you can check out previous videos in the Lingua Franca series. Anyway, let's do this. Ontologies. An ontology is an artifact which stores ontological resources for all entities, including the. Actually, let me quickly do a. Can type. GitHub Palantir. I think there was a. I think there was there's an SDK for the ontology stuff, I think. Though, of course, I can see it here. Because, I mean, I could have sworn that Yes, I can just search ontology. Ontology starter. Is the SDK? Yeah, it looks like it's auto-generated of some kind. Ontology starter. Anyway, it looks like they have an SDK, but they don't have it exposed publicly. Oh, it's not even TypeScript. Well, no, it is TypeScript. Where is the TypeScript file, config file? Oh, it's here. Yeah. Okay. Yeah, there's no. I was looking for the actual ontology SDK, but I don't think. Doesn't seem to be there. And that's a. Let's see what the defense SDK is. Let's just get back to the reading. Okay. An ontology is an artifact which stores ontological resources or entities, including the following. We call these resources ontology resources. I don't know, weirdly, just first thing that comes to mind is like Kubernetes resources. I wonder, can you model an ontology using a Kubernetes like configuration system? I don't know, that might be stupid, but anyway, just something that crossed my mind. An ontology can either be private and assigned to a single organization or shared among multiple organizations. Shared ontologies allow users of different organizations to share data and workflows in a safe way. Oh, by the way, speaking of ontologies and organizations, actually no, let me stay focused. Gosh, the reaction time on this is horrendous on my computer. Anyway, grouping entities in ontologies ensure that only users of the specified organization can access ontological entities. Users with access to multiple ontologies can switch between them by using the selection drop-down menu located in the top left of the ontology manager After an ontology has been migrated to roles, okay. Oh, has been migrated to roles. Okay. I thought it itself was becoming a role. It didn't make much sense. Members of that ontology will have discovered access to all ontological blah 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 whatever. Relation with spaces. An ontology is mapped one-to-one with a space. When a new space is created, a corresponding ontology with the same name is simultaneously created with the same organization markings as the space. A private space will map to a private ontology, while a shared space will map to a shared ontology. Well, is it private within the space? Or I'm not sure it's obvious what the what the privacy scope really is. Users and groups granted the owner role on the space also have the ontology owner role on the corresponding ontology. Makes sense. Okay, ontology proposals allow you to make changes to an ontology on a branch which is based on the main version of the ontology. This process ensures that all modifications are reviewed and approved before being incorporated into the main ontology. Oh, okay. Wait, this is more of a specific UX flows for I don't think I care about this right now. It's more administration stuff. Ontology. They don't really give you much about. Well, yes, there's not a whole lot to talk about. Again, this is more administration stuff. I don't think that's. I'm not interested in that right now. So let's say volume. Founders volume. Founders volume. Founders ontology is a fast access storage layer that allows you to bind object definitions to interactive data for queries, links, scenarios, and actions. Data in Foundry ontology is an index for fast access and for safe edits by multiple simultaneous editors. Ontology volume is a measure of the total size of the indexed object sets and their links with each other. Ontology volume is an average metric that's the unit of gigabyte for an instantaneous reading, whereas the unit of gigabyte per month, I think, or gigabyte month when measuring over the course of 1 month. Okay. Measuring intelligent volume, I don't care. This is more marketing stuff. Mm. 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 It's not very exciting. As in, I was hoping to see some coding examples, but I'm not. None of this is giving me the satisfaction right now. Let's see. Create an object type. This is all just. Okay, never mind. I don't think I want to go through all this ontology thing. Well, okay, maybe that specific section. Hmm. Huh. Huh. Yeah, there's nothing here that's very interesting to me right now. I think, yeah, a lot of it is just documentation. I guess I didn't do enough due diligence to look at the documentation. I thought there was going to be some code to look at. Instead, it's just typical user-facing documentation stuff, mostly. So we're gonna put the kibosh on that for now. What is this? Oh, Sky Palette. That's cool. That's cool. That's cool. But not tonight. Processes. I'll get to you someday. Y3 by example. Someday I'll get to you as well. Oh no. Oh, okay, so it is. Oh, the simulator. There is that. What time is it? 10 p.m. Actually, I think we're just gonna call it for this evening, at least for the stream. Probably gonna do a little bit more. Well, I don't know. Maybe I can just do a little bit more, but mostly just not really talk. And just do a little bit of study. And I have to decide what exactly I want to do. Because if I don't know, I'd rather go and make the most of the rest of tonight with some early sleep time. Maybe some TLA plus. All let's do is setup. I'm not feeling it. At least for this evening specifically. Stretch your back when you're sitting all day. Actually, let me see. Oh, it's the whole thing right there. Okay. Well, I guess you can also just go one at a time here. Some deep loading stuff. Maybe we should do this. Well, actually, maybe next month. I have been thinking about resuming my deep learning fundamentals journey. I think in January we did a series based on what's his name, the founder of Fast AI. I forgot his name, something Howard. Where can about. Yeah, this guy. What's his name? Jeremy Howard. Yes, him. We did the first course. His first course. I think it's called Deep Learning for Developers or Programmers or something. We did that, but I didn't really get a chance to follow through on that. Well, I guess I didn't give myself the chance to follow that through with. It's a two-part course. I did the first one, but then I guess just things got in the way, and I never got to the second part. But I'll be interested in, assuming that I vet this in the sense that, making sure that it's worth using as a basis for studying. Yeah, I wouldn't mind doing this. Oh, these are just typo stuff. But how come he didn't merge them? Why not merge it? Oh, okay. That's not him. It's somebody else. Is there somebody who actually went through the process of following this? Because they have a lot of PRs for adding changes to this. And yeah, and anyway. Okay. Anyway, so yeah, maybe next month do some deep learning. I think for this month, I think maybe I should lock in on well, I think what I could do. Because I was also planning on, so I guess, I also started a Kubernetes fundamentals series a while back. I think, I don't know where I stopped, but it was still in the very early stages of the Kubernetes documentation. I think I want to dive back into Kubernetes, and I think I would like to do that mostly in place of deep learning stuff. So now I need to decide how much time, at least from a streaming perspective, I want to spend on Kubernetes stuff versus starting to write some programs in Lingua Franca. And I think in order to have something that is focused, I was thinking about whether there is a way to translate the simulator code for this. Well, yeah, the simulator code, translate that into a Lingua Franca program, just to see how practical working with Lingua Franca is. Plus, I think, just re-implementing the simulator for this Limbo project will be interesting. Should be possibly a good gateway into becoming familiar um, with the code base, the overall code base. Ooh, not calling fsync. Oof. You gotta, yeah. If you're gonna build a database that's persistent, you gotta watch out for the fsync. So the current, I guess the current milestone is this, and so I guess this is a bug they found with the antithesis. Gosh, I'm definitely not saying that right. Antithesis. Yeah. Antithesis. Antithesis. Okay, never mind. Okay. Actually, let me see. What can I do? I think I can start by doing. Oh no. Okay. Yeah. Let's just do initial. I think, is it deep wiki? Okay. It's deep wiki. Alright, somebody already generated it. So you have the storage engine. Wait. How do I? Okay. There it is. Client interfaces, query processing, storage engine. I guess I also had a Let's Read the Code Base series on Limbo, which I also need to pick right back up. I'll pick back up. I don't see anything about the simulator here. Yeah, there's nothing about the simulator here. Oh, is it here? Testing your performance. Could be. Yep. Simulator. There it is. Simulation testing. Okay, so okay. Here we see our interface, plan generator, generate interaction plan, then plan runner. differential testing. Really execute plan, execution. Yeah. Okay. Guess I'm actually gonna call it for tonight. Although I do need to decide what I'm gonna do tomorrow. Um. It's either gonna be so it's either gonna be Kubernetes stuff or Lingua Franca stuff. I mean, yeah, Lingua Franca slash Limbo. Like I wanna actually build something with Lingua Franca, but I also want it to be something that's useful instead of just a toy program. Plus, I mean, I think ideally one of my goals this year is to make some contribution to the Limbo repo. So that could be a good way for me to start. But yeah, so some decision to make, because ideally, once I make the decision, I'll just stick to it for the next couple of streams, and it's less of a mental overhead for deciding what and when to do. I think I'm trying to be more mindful of, or at least be more on the side of consistency with a lot of the series of at least the topics that I'm engaging with. By topics, I mean specifically like, learning about Kubernetes. I'm learning about Lingua Franca. I'm reading the Limbo code base. I think the issue right now is that I don't do either one of those in long enough chunks that it's now at a point where it's a little there's a fragmentation of the content that I'm putting out. And I think I want to remedy that. I think I've done well to stick to the Lingua Franca reading material stuff, and so I should follow that up with something that I'm planning on sticking with for the next maybe 2+ weeks. So I need to decide that. So it's either gonna be, Kubernetes, which I think that was the second series that I started. I think I started with the deep learning stuff, then I did Kubernetes, and then I think I did the reading the material. So if we just go by even that just order, then I should be doing Kubernetes. So the end goal with the Kubernetes stuff, it's not going to be like, oh, so that I can pass some sort of certification or whatever. But at least I don't think I'll ever want to go down that specific or make that a goal. I don't. Yeah, I don't think so. But I think what will be interesting is once I learn the Kubernetes stuff extensively enough that I should be able to then write some sort of Kubernetes operator thing as a way to validate my understanding. But also, I think some time ago I came across a project. I think it's Anvil. Kubernetes controller GitHub. Yeah, this. An experimental framework to build practical family verify cluster manager controllers. Also, I'm not. Yeah, I don't know if this is to help you build controllers or okay. Controllers or operators. I guess this is specifically for controllers. Okay, verifying. Every is built on top of various tools for verifying those programs and Cube. So far, we have built and verified 3 Kubernetes controllers. Using area, we used yeah. So it's not. Anyway, I think the point is that when I do the Kubernetes stuff, I'll be keeping an eye out on the or maybe it'll be that the end goal to feel like it was all worth it would be to implement an existing operator but in a different language or whatever. Did this just okay, never mind, 6 years ago, because I think I was browsing YouTube and I saw a video that was referencing this this particular project, and I don't know, for a second there I thought it was a new thing, but no. MySQL operator. Mm-mm. 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 Cloud Native Manager. Flight. Wait, which company did flight come from? If I remember right, Metaflow is Netflix. Is flight Meta, as in Facebook? I think it might be. Black Shark AI. What's up with that? Never heard of them before. Ooh. Interesting. Wait. Oversubscribed extension? The fuck does that even mean? Okay. Wow. That sounds impressive.
Blackshark.ai presents Synth 3D, the first photorealistic 3D replica of the surface and infrastructure of the entire globe. It contains all the terrain, vegetation, and infrastructure and is ready for large-scale simulation, training, and visualization applications. Synth 3D includes every country, city, building, and detail in a region-specific and geotypical way. In addition to realistic textures, it contains semantic metadata and material attributes of all objects, models, all base map by Blackshark's AI-powered geospatial platform, extracting relevant information with unprecedented speed and scale. And as Maxar Vivid is continuously updated, Synth 3D always stays current. With the Blackshark Globe plugin for Unreal Engine, any geo-reference data can easily be integrated and combined with Blackshark Synth 3D, and is ready to be integrated into your application wherever it's needed. At Blackshark, we put the whole world in your hands.
Alright. Geointelligence at scale. Man, there are entire domains of industries that you're like, oh yeah, I bet this is something that's very useful and lucrative as a business. I mean, if you do it well. Geospatial analytics. Anyway, how did we end up here again? Okay. Oh load. Okay, so it's this task and then the transform. Yeah. Anyway, seems pretty solid. Wait, more than wasn't that the stuff made by um the Germans? I forgot specifically. Anyway. Yeah, never mind this. Oops. Hmm. Yeah, I think I was originally interested in how it came to be. Is that Facebook slash AI? So this is the commercial version of Flight. Yeah, that's what it looks like. Yeah. Oh, it's written in Go. Interesting. Wait, if it's written in Go. Oh, and they have a Python SDK. Oh. But I don't. Oh, it says 1%. Where's the actual Python stuff? Like, I'm aware that it's common practice these days to write Python packages using Rust. I just did not know that Go also entered the chat on that one. Maybe I'm missing something. Anyway, I'm pretty sure I said I'm gonna call it a night like 30 minutes ago. Anyway, flight. I think I got here because I was looking for I was suggesting that one of the an end goal for learning the Kubernetes stuff would be then to be in a position where I can write an operator. And by that I mean not necessarily building one from scratch, but at least building one that is based on an existing one. Maybe since this is written in Go, maybe we write it in Rust. So typical. We write everything in Rust. Or I might just decide to rewrite it in C++ because, I love pain and misery. Well, I'm sure you can write a decent Kubernetes operator in C or C++. It's just that people aren't really doing it, as far as I'm aware. Okay, so Zolando has theirs. Crunchy Data has theirs. How about for MySQL though? Like MySQL Kubernetes operator. Maybe if I do this. Oh, this is the most popular one. That's not very interesting. Okay, so there's flight, there is... Wait, they have... The flight thing has its own Kubernetes. Kubernetes operator. Oh, there is. Maybe it does, actually. This is just testing. It just might be testing only. I don't know. Anyway, but you get the point. Apache Kafka running on Kubernetes. Anyway, so yeah, learning Kubernetes so that I can write AI. an operator, and resuming. So it's between that or focusing, spending more time on Lingua Franca, but with the goal of using that to write an alternate version of the Limbo sequel. Um, the Limbo sequel database. I mean, no, not the whole database. Limbo sequel simulator. The simulator. That's what I meant. Yeah, this. So yeah, I think I need to decide that. Anyway, it's good time to call it for tonight. But yeah, we'll resume tomorrow with either one of the two things that I've just mentioned, and we'll try to just stick to that for the next, maybe for the entire month, actually, the whole month of May, so that we have a really good run on a particular thing for a while until we decide to switch to something else. I think that'll be a good thing going forward, to put in some consistency instead of switching between different contexts. Yeah. All right. All right, people. Good night. Good night. Good night. Good night.